This is a continuation of 8.1 review. So for number 13, very similar to number 10, we're going to let u be what's inside this parentheses because its derivative is very similar to this, just missing a constant. That's a factor. So let's go and look at number 10. 13 is very similar to number 10. So we're going to let u be 1 plus e to the negative x. The derivative of this u is, derivative of 1 is 0. Derivative of e to the negative x is e to the negative x times derivative of negative x, which is negative 1. And we'll put a dx here. So we need to multiply this by negative 1 and multiply the outside by negative 1 because negative e to the negative x dx is du. So rewrite the question, negative. So in place of negative e to the negative x dx, we'll put du. And this is 1 plus e to the negative x, which is u squared. Okay. Note, those of you who got this review in class, there was a typo and this negative was missing in the question next to this first e. This should have been e to the negative x. Okay. So we're going to take the antiderivative using power rule. So we get negative 1/3 u cubed plus c. So replace u with its equivalent, 1 plus e to the negative x cubed plus c. Double check. This is our double check column. Number 13. Take the derivative. The derivative of this using power rule is negative 1/3 times 3. 1 plus e to the negative x squared. Using chain rule, now take the derivative of inside, and the derivative of the inside, derivative of 1 is 0, derivative of e to the negative x is negative e to the negative x. These cancel, you get 1. Negative times negative is positive, so we get e to the x, 1 plus e to the negative x, 1 plus e to the negative x squared. And that is the equivalent of what we started out with. Moving on to number 14. Number 14, we can't use u-substitution because 1 plus e to the x, if we use that as u, then its derivative, which is e to the x, is not out here being multiplied by this factor. So what we're going to do is we're going to FOIL this. We're going to multiply this out, distribute it. We're going to square this. So this becomes 1 squared, which is 1, plus 2e to the x, plus e to the x squared, which is e to the 2x. Okay, so now we take the antiderivative of each part. Antiderivative of 1 is x. Antiderivative of, I'm sorry, we're taking the antiderivative, so we don't put the antiderivative symbol anymore. Antiderivative of 2e to the x is 2e to the x. And antiderivative of e to the 2x is 1/2 e to the 2x. Don't forget the plus c part. In case you're wondering why antiderivative of e to the 2x is 1/2 e to the x, refer back to number 12, which was in the previous video explained. Okay, double check number 14 by taking the derivative. Derivative of x is 1. Derivative of 2e to the x is 2e to the x. And just this derivative is 1/2 times e to the 2x times 2. The times 2 part is derivative of 2x, and derivative of a constant is 0. So this is 1 plus e, 2e to the x plus e to the 2x, which factors into 1 plus e to the x squared. So it does check. Okay. Now let's do number 15. Here we let u be e to the x plus 1. This is very similar to number 13. In fact, it's almost identical. Once we rewrite it, this will become to the -2. Very, very similar. And these exponents are negative in here, and here they're positive. So u is going to be e to the x plus 1. Du is e to the x dx. The rewrite will be the antiderivative, e to the x dx, that's du, over u squared. Rewrite it as a negative exponent, take the antiderivative, add 1 to -2, that becomes -1, divide by that new exponent, we were using power rule, plus c. Change it back, so that's -1 over u, and u is e to the x plus 1. Double check by taking the antiderivative, by taking the derivative. So the derivative of, rewrite this as an exponent and use chain rule. So this is really -1. Let's move this a little bit. E to the x plus 1 to the -1. So the derivative, -1 times -1 is +1. E to the x plus 1 to the -2 times derivative of what's inside, which is e to the x. And that is, in fact, what we started out with, e to the x over e to the x plus 1 to the second.